Hello, math students. We're still working in Module 1, Ratios and Unit Rates. And today's lesson is Lesson 2, and it's called Equivalent Ratios. The goal for today we are going to learn how to use tape diagrams to make equivalent ratios. The question that I want you to be thinking about is, how can you use the original ratio tape diagram to show equivalent ratios? Some things that we need to learn. We're going to start it off with a task. Shani and Mel are using ribbon to decorate a project in art class. The ratio of the length of Shani's ribbon to Mel's ribbon is 7:3. So the first thing that we have to figure out is, what is this task about? And what I would say that this task is about, by reading it again, Shani and Mel are using ribbon to decorate a project in art class. The ratio of the length of Shani's ribbon to Mel's ribbon is 7:3. So again, we're using ratios again. And what this task is about is the ratio of Shani's ribbon to Mel's ribbon. So, and here, what is the task about? We would put the ratio of Shani's ribbon to Mel's ribbon. Okay, that's what the task is about. What are the quantities in the task? Now you need to remember what a quantity is, and a quantity means that there is a unit of measure combined with a number. So we're going to say that Shani's ribbon is 7, and we're probably going to say it's inches, so the units of measure would be inches, and Mel's ribbon is 3 inches, so the quantity would be 7 inches and 3 inches, okay? The relationship of the quantities are, for every 7 inches of Shani's ribbon, there is 3 inches of Mel's ribbon. So remember, in yesterday's lesson, we talked about how you use this sentence starter for the relationship. And so the relationship that we have here is, for every 7 inches of Shani's ribbon, there is 3 inches of Mel's ribbon. So that gives you the relationship. So then we're going into, how do we model a ratio relationship? And there are 2 different ways. And the 2 different ways that I'm going to teach you today is, one way is by using a table, and the other way is by using a tape diagram. Okay? And so our goal said that we were going to focus on using tape diagrams. And so we're going to take what we did yesterday in the lesson with the tables, and we're going to convert it to tape diagrams. So if we have a table and we know that Shani is 7 and Mel is 3, then we can keep going and say, well, what happens when Shani has 14, Mel has 6? And when Shani has 21, then Mel will have 9. And the way that we know that is, you're just increasing the values. So you ask yourself, how did you get from 7 to 14? You multiplied it by 2. What you do to one side, you have to do to the other, so 3 times 2 is 6. How did you get from 7 to 21? You multiplied it by 3, so what you do to one side, you have to do to the other, so 3 times 3 is 9. So that's how we show it, okay? A tape diagram is actual visual representation that's very helpful, and its name comes from the fact that we used to use tape. We'd stretch the tape out, and then we would break it into sections. And so Shani has 7 sections in her tape, and Mel has 3 sections in her tape. So that's how we would describe the 7:3 ratio, because there's 1, 2, 3, 4, 5, 6, 7 for Shani, 1, 2, 3 for Mel. And so that's what the ratio looks like using the tape diagram, okay? So if we keep going, we're going to look some more at tape diagrams, okay? And what we just showed on the other side was the ratio of 7:3, so we count them. 1, 2, 3, 4, 5, 6, 7. So we would write 7, 2, 1, 2, 3. And that's the original ratio. Shani was 7:3. Okay, now what if I tell you that the value inside the tape is no longer just 1, let's say that the value is now 2. So we would go 2, 4, 6, 8, 10, 12, 14, and 2, 4, 6. So that is the ratio when we have the value be 2. Now we're going to put the value as 3. So 3, 6, 9, 12, 15, 18, 21, 2, 3, 6, 9. Now, I want you to look very closely at these tape diagrams because the only thing that we did was we changed the value of what the inside of the tape holds. We started out with being 1, then we changed it to 2, then we changed it to 3. Well, if you review our use of the table, in the first one, when each one was worth 1, we got a ratio of 7 to 3. And you look at this table, what is the ratio? 7 to 3. Now we change the value of the inside of the tape to equal 2. So everything, remember, tape diagram sections are the same size, same shape. So if this is a 2, all of them have to be 2 because tape diagrams are the same size, same shape. So now if we look on our table, we have 14 to 6 as a ratio, and look at that, 14 to 6. So we can show actually how it happens by looking at the tapes. Again, each section is worth 3, 3, 6, 9, 12, 15, 18, 21. So there's our 21, 3, 6, 9, there's the 9, and you will notice that that ratio matches the ratio in the table. Okay, so it's just another way to show the different kinds of ratios that are associated with Shani and Mel's ribbon. Okay, so now let's look at some questions. What would happen if each section of the tape diagram was worth 1 inch? Okay, in this one, if it was 1 inch, the ratio would be 7 inches to 3 inches. Okay, so now what happens if it's 2 meters? So now our units have changed to meters, and our ratio would be, everybody, 14 meters to 6 meters. Okay, and then our last one, it says to feet, so our units changed again, and this time it would be, looking up here because we said 3 feet, it would be 21 feet to 9 feet. Okay, so that's how we would answer the questions. What would happen if each section of tape was worth these different amounts? Then you would come up with these different types of ratios and ratio relationships, because remember, these are quantities. Because they have units of measure, it makes them quantities. Okay, these are just ratios. These are ratio relationships because they have the quantities, the units of measure. Okay, did the actual tape diagram change? Look at it. Did the tape diagram in shape or size actually change? Nope, there's 7 squares on the top and 3 squares on the bottom. 7 squares on the top, 3 squares on the bottom. 7 squares on the top, 3 squares on the bottom. So to answer that question, did the actual tape diagram change? The answer is no. Okay, the next question asks you, what did change? Think about it. What did change? Hopefully you came up with the answer of the value of each section of the tape. Okay, that's what changed. So in this one, the value was 1 per section. In this one, the value was 2 per section. In this one, the value was 3 per section. So what did change was the value of each section of the tape. Okay? When the values in each section change, equivalent ratios are formed. Equivalent ratios means ratios that are equal. So if we start out with Shani and Mel, remember, writing it as a fraction is another way to show ratios. So we have Shani to Mel, 7 to 3, because that was the original one that they gave us. Then, when we changed the inside of the tape's value, we found an equivalent ratio, and 7 to 3 is equal to 14 to 6, which is equal to 21 to 9. So we could say in this part right here that all 3 of these ratios are equivalent. So for this example, we have three equivalent ratios. They equal each other because the value of the sections changed. So, how do you make equivalent ratios? If there's an assignment practice problem that says make three equivalent ratios, what you need to tell yourself is that you need to change the value of the sections in the tape. And when you change the value of the sections in the tape, then you have equivalent ratios. Okay, so it's pretty simple. The thing I love about tape diagrams is that they're visual and it helps you to see everything that's going on, and so it makes more sense to me. I'm a very visual learner. Okay, moving on to the last page of our notes. Oh, this one is so fun. You're going to love it. Practice task. So this is actual math that you need to do. Okay, so practice task says the candy jar holds green apple Jolly Ranchers and red hot Jawbreakers. What is the ratio of Jolly Ranchers to Jawbreakers? Because we can't see colors, the thing that I want you to know is that Jawbreakers are usually round. So we're going to say that these guys right here, the round ones, are the Jawbreakers. If you buy Jawbreakers in the store, they're round, okay? And then we know that Jolly Ranchers typically are rectangular in shape. And so since I don't have a color printer and you can't see the actual colors, we're going to say the rectangles are the Jolly Ranchers. So make sure that you see that when you're trying to figure out this problem. So on the first question, you have to write a ratio of Jolly Ranchers to Jawbreakers. So I would pay very, very close attention to that language, Jolly Ranchers to Jawbreakers. So the key word is right there, so that should help you, okay? And then the other thing that you're going to do is you are going to write two more. Oh my gosh, Mrs. Nelson, I can't believe you did that. Fix that. This right here is the wrong two. Cross it out. I need you to fix that. I was typing too fast. That's what happens when you go too fast. Okay, write two more equivalent ratios to your answers above, okay? So whatever you got the answer for this one is, you have to make two more equivalent ratios. Again, you could use a fraction bar if you wanted to help you. So one thing that I would like to do to help you set it up is it says Jolly Ranchers to Jawbreakers. So we're going to do Jolly Ranchers to Jawbreakers. Okay, and that's how I would set it up. So you're going to take your ratio from up here, Jolly Ranchers to Jawbreakers, and then you have to find one more, and then you have to find one more. You might want to use a tape diagram to help you if the tape diagrams helped you see it. All right, kiddos? So we learned quite a bit about ratios and tape diagrams going back to our goal for our lesson. Today we are going to learn how to use tape diagrams to make equivalent ratios. We did just that, and it's pretty awesome once you figure it out. Let's go back to your question that you were supposed to be thinking about during the lesson. How can you use original tape diagrams to show equivalent ratios? I will give you a big, gigantic hint. Ta-da! One more time, big, gigantic hint. Ta-da! How can you use original tape diagrams to show equivalent ratios? So, two things I'm looking for on a TLC check tomorrow. The answer to this question, your question for the lesson, and then I'm also looking for the answers to this practice task. So that's what I will be looking for when I check in with your video watching tomorrow for TLC. All right, kiddos, that's all I have for you today. I'll talk to you soon. Bye.